You've got data to store, a to-do list where order matters, a set of unique user IDs with no repeats, a phone book mapping a name to a number, or people waiting in a line. Java has a perfect container for each, and picking the wrong one can make your code crawl. Welcome to the collections framework. It all starts with one family tree. Everything begins with iterable, which leads to collection, the root of most containers. Collection branches into three big interfaces: list, queue, and set. Each solves a different problem. But there's one important outsider. Map is not a collection. Instead of single elements, a map stores key to value pairs like a dictionary. So remember, list, set, and queue are collections. Map sits in its own family. Let's start with list. Ordered, indexed, and it allows duplicates. The default list is array list, and inside it's just a resizable array. Because elements sit side by side, getting any index is instant, constant time. The catch: inserting in the middle has to shift everything after it, which is linear time. The other list is linked list. Instead of an array, it's a chain of nodes, each pointing to the next and previous. Adding or removing at the ends is instant, but there's no indexing. To reach the fifth element, you must walk node by node, which is linear time. So, which list? Array list is the everyday winner, fast reads and compact memory. Reach for linked list only when you constantly add and remove at the ends. And vector is the old synchronized version. Skip it unless you specifically need its legacy behavior. Next, set. Its one job is no duplicates. And the secret of hash set is that it barely does any work itself. Inside, it just holds a hash map. When you call set.add of an element, it really calls map.put, using your element as the key and a constant dummy value called present. Remove and contains delegate the same way. Because every element becomes a key and a map can't have duplicate keys, duplicates are impossible, and you get the same constant time performance as hash map. Need order? Tree set keeps its elements sorted at all times using a balanced tree at logarithmic cost per operation. And if you just want to remember insertion order, linked hash set does that while staying constant time. Now map, key to value pairs with no duplicate keys, and hash map is the workhorse. So how does it actually work? Inside, it's an array of buckets. Each bucket holds a linked list of nodes called entries, and every node stores four things: the key's hash, the key, the value, and a next pointer to the following node. When you put a key, HashMap uses its hash to pick a bucket. If two keys land in the same bucket, they chain together through those next pointers. Lookups are constant time on average, and since Java 8, if a single bucket grows past about 8 nodes, it is upgraded from a list into a balanced red-black tree, so even the worst case stays at log n. Two cousins rounded out. TreeMap keeps keys sorted using a red-black tree at logarithmic cost. Linked HashMap keeps insertion order at constant time. And Hashtable is the legacy synchronized map. Today we prefer concurrent hash map for thread safety. That leaves queue. When you need to add and remove from both ends, ArrayDec is the answer. A circular array that's constant time at the front and the back. It's the modern, faster choice for both a stack and a queue. Priority queue is special. It's a binary heap that always keeps the smallest element on top. Peaking at that minimum is instant, while inserting and removing are logarithmic. Perfect when you always need the highest priority item first. Here's the one cheat sheet to memorize. Array list, instant index, linear middle insert. Linked list, instant at the ends, linear lookup. Hash-based sets and maps. Constant time, no order. Tree-based ones, logarithmic, but sorted. Know this table, and you can answer almost any collections question. So, which one? Mostly reading by index? Array list, adding at both ends? ArrayDeki? Unique items, hash set, or tree set if you need them sorted. Looking things up by key, hash map or tree map for sorted keys. Need insertion order, the linked versions. Always want the smallest first. Priority queue. The whole picture: list, ordered and indexed, duplicates allowed. Set, unique elements. Map, key to value pairs. Queue, items processed in a specific order. Pick the structure that matches your problem, and the performance takes care of itself. Interview time. What's the difference between list, set, and map? A list is ordered and indexed and allows duplicates. A set holds only unique elements. A map stores key-to-value pairs, and unlike the others, it isn't a collection. Array list versus linked list. Array list is a resizable array. Instant index access, but shifting makes middle inserts linear. Linked list is a node chain. Instant add and remove at the ends, but lookups are linear, default to array list. Hashmap, tree map, or linked hashmap. Hashmap is constant time with no order. Tree map keeps keys sorted at logarithmic cost. Linked hashmap keeps insertion order while staying constant time. How does a set guarantee no duplicates? A set is actually backed by a map. The elements are stored as the keys, and since a map can't have duplicate keys, duplicates simply collapse. Hash set uses a hash map. Tree set uses a tree map. Array dake versus priority queue. Array dake is constant time at both ends, the go-to stack and queue. Priority queue is a heap that always returns the smallest element first, with logarithmic inserts and removals. Now it's your turn. Take the topic test and lock it in. 5 multiple choice plus 5 short answers, graded by AI. The link is in the description below. And here's something special. Top the leaderboard on 5 topics in a row, and you'll get a surprise gift from me, plus a personal one-on-one connect.